Alright, everybody. So I promise that this skill is going to take less time than the other skill. Alright, so now we're going to look at right angles and then different shapes. So let's begin with the right angles. So let's just start with this model right here. You can tell that the right angles, and that's probably not the most right angle one. And there's different symbols or shapes, but let's just start out here. Okay, and that's not. It's like I feel like I need a ruler to make that straight or something. Okay, I'm gonna do my best to make it as straight as I can. Okay, well, okay. So this is a right angle. Okay, so that this is a right angle. Not necessarily a shape. We'll get to that. But when it has a line here, and then, okay, I'm trying to see if there's a way to explain. So, you see, there's a point here on the line. Okay, so if I'm drawing two lines, let's say like this, in between there's a little bit of a point there. And on that point, on the bottom of it, if that bottom line isn't like a straight line, then it's not considered a right angle. And there's a way to tell by drawing a shape that looks like that. Okay, so that's probably not the world's most straight and perfect line, but I think that it's easy enough to be able to tell this would be a right angle. If I can draw a symbol, okay, and I'm probably gonna draw this out because it's gonna rack my brain to have to explain. Okay, but if I can draw a symbol like this, like a little box symbol, okay, and then it looks like that will begin where it starts, and then and then and this side of it ends on a straight line. So just easier way to explain this. So we have this, and then we have and this right here would be the end of the point, and then let's say, because we want to draw it above that point, let's say, well, no, that would not be, so this would not be a right angle, because that bottom line is not straight. It kind of goes down. It kind of, it doesn't, well, yeah. It also matters what line is above. So what line is, the higher line. Because you need, in order to form a right angle, you need the up and then the bottom lines to be perfectly, and that's not perfectly, but you're just looking straight. And so this line goes, say, southwest to northeast, and then southeast to northwest. So it's not just either, say, north, like straight up, and then west to east, straight down. So, actually, north if you're going up, south if you're going down, and then across. So, east if you're going, and I'm actually going to draw the directions for you to see here. Okay, so north is heading this way. North is heading up. Okay, so you can see the arrow, and you can see also the line as well. This is an up line. This is a down line. Also depends on going in the mouth of the arrow what this shape is. so left, right, up, down. Left, right, up, down. Okay, so I hope that you can see what I have there. Okay, so yeah, okay. So if the upside and the downside are both straight, okay, there's no like like slantings or angles or rounds like that, then that means that you can draw that little box symbol on on the top on the top line before that little corner point, and then drawing it across and then down. It doesn't matter how long and across length that you draw it out or up length. It's all about the the real shaping of it. Not the size or not the cross or up whatever. But it's all about the angling of it. The degrees of it. So if up line, down line are straight, and I draw a little square like shape, and it looks like this, going with the actual shape, that would be a right angle. Okay? So if I were to draw, say, this right here, that would not be a right angle, and I'm trying to think of a way there's several ways to do this, but okay. Well, no. Well, yeah. Okay, so, yeah, I already explained. That would not be right angle. I'm not going to get into all the different types of angles and all the different types of degrees, because I don't know all that stuff. But I do know right angles, okay? So I'm just going to teach what I know, okay? So we have a right angle. Now we're going to do a right angle shape. We're going to do some right angle shapes. So we have this shape right here. Okay, so I want you looking. So this shape right here, as we know, has all straight lines on up, down, right, left, north, south, east, and west. Okay, so all of these are straight. There's no circles, there's no slants or diagonals. So actually, as I said, top, bottom, baseline, I want to say, and then height line, if they're both straight, looking something like this, okay, then that means that we have right angle. Okay, I hope that you all are getting this, because I think I'm doing amazing at explaining this. And if you want, we can just fill that in here. So this would be, this is a rectangle, and we're also going to take a look at, all the different shapes and how many, sides that they have, to a certain extent. Even I can't remember how many shapes that all the, how many, the number of sides that all the shapes have. So much information. Okay, but, so this is a right angle shape. We're gonna, I want you to point out where you can draw in the right angles and where can't you. So this is a right angle shape. What about this? Is that a right angle shape? Can somebody tell me? Is that, is a circle a right angle shape? If it's not, the height and then the base is not, like, perfectly aligned straight. There's a bit of a curvature in a circle, because it, circles, obviously. No, it is not. It is not. I mean, you could still draw that. It's still possible to draw, the little box, either there or, say, there, or there, or there, and then, shade it in. But it has to really do, okay, if there's space, there's a little bit of space, to put those things in, that's not what it means. The base and height is perfectly in straight lines in that right angle. There's no slant angles, there's no, there's no nothing. So that would not be, right? Okay, you can see the same with a square. Okay, that was more of a rectangle, so let me do a, pretty thin one. So this shape right here, although it's small to see, and I'll make it bigger so that you can see here, okay, is a square. Okay, square has 4 sides, and then a rectangle is like a fatter, more widened square, as you know. And so, with this, because both top line, bottom line are, straight on all of the different sides, all of the sides are equal to each other, and they're all straight, like there's no curvatures. On the little corners, those are all right angles. Meaning, and they're probably not perfect right angles, but they're, good enough. So that means that we can, draw those things in, and that would be considered right angle. Now we're going to move on to another shape. And this shape is going to be a triangle. A triangle. On a triangle, as you know, has 3 sides. And a triangle has a bit of a slant. So, let's see here. If I'm thinking right, alright. Northeast to southwest, northwest to southeast. So, okay. Southwest, northeast, northwest, southeast. Okay, so there's a bottom base, so we have that running, but then we have 2 slants. Looks like like a lot of those houses have the triangular shape to it. On the rooftop and everything, on the shape of the house outside. So, because of that slanting, because the bottom and the sides are not equal to each other perfectly, perfectly straight, bottom and then height, perfectly straight. In this case, it's not. That's another type of angle. But the most important thing to determine not right angles, but just angles in degrees, is if all the sides, all the sides, because it will matter, are equal. Okay? So, these sides aren't equal. You have the bottom straight base and then the slanting. So that would not be considered a right angle. You could still draw the shape in. You could still draw the little symbol in. But no, that wouldn't be a right angle. Now I'm going to get a little bit crazy here, and I'm going to draw this shape right here. This little shape. Look how crazy that is. Okay, look how crazy this is. Well, it wouldn't be considered a shape. Actually, well, it would, but there's no corners. Okay, there's no corners, and nothing is connected to each other. And because it is a curvature, because it just circles around, just and then up, and like that. Okay, kind of looks like a tail. There's no right angles because the sides aren't connected, and they're not even on the base and then the up. So, as I said again, you could probably still draw those shapes in. They're going to look different, depending on, what the shape is. But, well, okay, you can draw a couple of those in down there, I guess. I'm not the best drawer in the world, so, yeah. But look at that. I mean, is it me? Or am I struggling to find the places to draw those shapes in? Is it me? Am I having a tough time? Or is it hard to find to draw those little symbols in? Well, I'm going to just blame it on the shape. Okay, because nothing is connected to each other. So, now we're going to do a little bit of a fusion. We're going to fuse them together. Okay, so, let's see here. Let's just fuse them together. So, we have this shape here. And then we have something that looks like this. Okay, per se. So, let's see here. So we have this shape right here. Okay? So, with the shape, there are a couple of right angles. There is a couple of right angles that we can see here, because, the top with the bottom, and then, those are interlinked to each other. Okay? So, this is this, although it looks like a big equal sign, are interlinked. So this would be the top of the shape. This would be the bottom of it. And then that and that, north, south, east, west, the sides of the shape, right, left. So, side, right, side, left, and I'll just put the directions as well. So, south, let's see here, west, east. So these are interlinked, and then the sides are interlinked. Okay, so with that, so they all need to be connected, and they all need to be equal in their the shape. Okay, so the either one or so the sides or one side and the top and the bottom need to be equal. Okay, so the sides are straight, the bottom or top is straight. Or the side is straight, bottom or top is straight. And like the bottom, say isn't straight, then the sides are like, kind of like like slanting, like the triangle. So that they're equal, that would make it, and if it's perfectly straight, that's not perfectly straight, but then we have the right angles that we can draw in those shapes on all the different sides of it. But then this shape, okay, that's as far as we can go. Because then we have this curving around, and, well, nothing's connected, nothing's equal, nothing's straight, nothing is 90 degrees, and I cannot find, the proper areas to draw those little symbols in. Okay? So that's what I wanted to teach you about right angles. Okay, now what we're going to move on to is do a couple of story problems here, of which I don't want to have to write out for you, but we're going to be using and you should already just basic computational things, like 9 plus 2 and all those types of things. That's not what we're going to be talking about at all. Okay, so remember, so now we're going to move on to story problems. Okay, and so with story problems, okay, this is as far as we're going to get to today, alright? So for story problems, addition, adding, increasing, subtraction, minusing, decreasing, double super increasing, and then you're kind of I want to use the term middle decreasing. So we have increase, big, bigger, decrease, smaller, double, or super increase, and then middle decrease. So, as I said, addition and multiplication are interlinked, having, increasing, multiplication and division all interlinked. Although they're different, they're, the same in the way that they both decrease. But division is the one that is the middle decrease. So if we're talking about story problems, addition would be total. So, if you're looking in story problems, there's a story and then there's numbers, then, the telltale sign to find, to be able to tell that, the problem is an addition problem is if it has the word total, like how many total, whatever. With the numbers and then the words and then, the scenario and whatever. So, subtraction, actually, well, okay, that's, okay, you're gonna find this ironic. I'm trying to think here, what to do. So, although it would be obvious to say less, you could, if I was reading a story problem and I saw the word less, it was like, okay, subtraction. But when it comes to subtraction, two opposites are the same. Meaning that another word to tell if it's subtraction is ironically saying more. Now, that's ironic because you would think, as we know, addition increases. We're going to find out a higher number. But the subtraction decreases, finding a lower number. And then multiplication, even a huge, bigger number. And then division is the middle number. Okay? But so, what subtraction decreases, and then addition increases. So let's just stick with these two for now. But so for a subtraction problem, in a story problem, saying the word more for subtraction is getting less, and more is increasing. More is getting bigger. Subtraction is getting smaller. But in my judgment, it's a comparison between two things. But, so that's another word. And then, let's see. And then also, left. There's another word. Not like the direction, but like, how many of this does someone have left? Like left over. Still remaining. So, that's another telltale sign. And then, let's see here. So then, multiplication is times. That's the only one that I can think of. Is there any other words in story problems with multiplication that anyone can think of in here? Okay. So, times. Obviously, if we're timesing, we are multiplying. So, times. Just in a particular situation, 6 times, or writing 6 times 8, having a number form as we know in 48, and then say, writing it in letter form, 6 times 8 equals completely, or, the equals can be, in whatever, word or number, written out like that, or just in the word form, and then 48, write the number out. So yeah, so times, and then, alright, let's see here, I'm trying to think of division. I can't really think of anything for division. Yeah, it's not really coming to mind. So, alright, I can't really think of any words for that. Yeah, I'm trying to sit here and think about it, and I can't. Well, okay, nothing's coming to mind, but I think that you get, for the most of it, okay? So, let's look at one story problem. So, I want to say that, I'm going to be using the words, going with all the different operations. Okay, so let's say, I don't know, that John, and by the way, I lied when I said we're going to be going through all of the information today, okay? As I said, I'm spontaneous. And here's what I'm going to tell you, is that today we're going to finish with this, and then we're going to, and then on another segment we're going to be doing charts, and then a couple of other things, and then, it's going to be divided into segments, okay? So this is going to be the end of this segment after this, okay? But I just had the list of all the things that we'll be looking at. So, John has, okay, I'm trying to think here. Oh my goodness. Alright, John has 25 pages of a book. Okay, wait. Okay, John has, say, 120 pages of a book, to read. Okay? And then Nina has 100 pages of a book to read. And then, so we're asking, how many more pages of the book does John have? So, let's see here. So to be able to do this, we would be subtracting. We would be subtracting because we would be using more. So, we would be subtracting 120 minus 100. So John, alright. Is that even right? Look, okay, taking 100 and then 20 more pages from the 100. Okay, so now that you've seen subtraction, let's go on to addition. So, let's see here, addition. So, alright, so Alex has 40 bananas. Amanda has 70 bananas. What is the total number of bananas? So total, we're taking 70 plus 40. 70 bananas plus 40 bananas, how many in total? In all. In all is another word I forgot to add in for addition. And then average. So, drop the zeros down to 7, 8, 9, 10, 11. So, 110 in all. Okay, as the total answer for that, okay? So, let's see here. Okay. Okay. We're gonna move on to, alright. Okay, so, actually, I have one for division that I want to do. So, alright. So, I can't really think of any words for it, but I might have an idea for that. So, an auditorium has, I don't know, 200. Oh wait, that's gonna be okay. What's the what? Okay, 111 seats. 111 seats, and then there are about 6 seats in each row, and then it's asking how many rows are there? How many rows of seats? So we know that the auditorium, 111 seats, and those 6 seats in each row. To be able to find out how many rows that we're having, not the seats in each row, but just the one, single rows. We could do it the long way, or we could do it, the easier way. So anyone have an idea for this one of what we could do? Yes. Exactly. So we would be dividing. Again, the middle number. So we already know the total number. We already know the total. And the total is, the total number of seats. 111. So then we know the 6 seats in each row. So the middle number. So we take 111 divided by 6. 111 divided by 6. So to be able to do this the long way, we would do 6, and then goes into it one time, and then 6, 11 to 9, 8, 7, 6, 5. Then drop the 1 down, 6 into 51. Let's see here. Okay, 8 times minus 48, and then carry, and then 11 to 9, 8, 7, 6, 5, 4, 3, and then 18. That's my guesstimate on it. Although you could try to put it into the calculator and try to see. Okay, so that's that. And then, let's see here. So, let's do chickens. Let's do chickens. So, one farm has 20 chickens. Another farm has